determination of production units for a dairy manufacturing company, which is a seasonal product, that is demand forecasting. This is very important part for any manufacturing organization. Demand with probability is known for this industry. From the past data, it is drawn as the demand for 10,000 units is 0.1. The probability is 1. Probability with demand is known. 20,000 units, that is 20,000 units of dairy, the demand is 0.35. 40,000 units, the demand is 0.35. And 60,000 units, demand is 0.25. The sum total of the probability is 1. We will use Monte Carlo simulation technique to solve this problem. For getting the demand at random, we have to use the random number. In Excel sheet, random number is easily available. If in any cell, if you write this formula is equal to RAND, then the random number will be shown. And it is automatically developed, and if as electronic sheet is connected, all cells are connected, if you write any figure to any cell, automatically it will change. I am showing you how the random number will come. Suppose I am writing in this cell as is equal to RAND in bracket, then you will see the random number will come here. And if you strike or write anything to any cell, it will automatically change. This is changed. Actually, this random number is coming with the help of this function, Excel function. Now, how you will connect the demand with the random number? Because we have to calculate or forecast the demand with the random demand. For getting that random demand amount, we have to connect the demand with the random number with the help of Excel sheet. For this purpose, what you will do? First, cumulate the probabilities for the demand units. How you will cumulate it? See, 0.1 first, then add 0.35, after addition 0.45, then 0.35, sorry 0.3, 0.75, and finally 0.25, that means 1. What it indicates? This is again written here in the data range. This means if the random number value is just below 0.1, that is more than 0 and below 0.1, then the demand will be considered as 10,000, and 0.12 just below 0.45, the demand will be 20,000, in this way. And more than 0.45 and just below 0.75, the value of random number, the demand will be 40,000. In this way, we have allocated the demand with the probabilities, cumulative probabilities, and this will be attached with the random number. How will attach? You see, this range of data is attached with the name variable. In this case, it is say lookup 1. Lookup 1 is a name variable which represents this data range. and it will be used for finding out the demand amount. We have kept also lookup also, that is in the first sheet we have seen. Two variables are used. You can take any one. So we have taken the lookup variable. Lookup is the variable, name variable which represents this data. How will connect the demand amount with the random variable amount? The random variable, random number is written here with the help of formula. This is random number, and for every cell it is random. And here the formula is written. VLOOKUP formula of Excel will be used to connect the random number value with the demand. What is the formula? It is shown here. Is equal to VLOOKUP B12. B12, this is the value. If the value is this, then what will be the demand? The demand is this. You can check it from the table. That 0.176, where it is located, 0.176 is more than 0.1 but below 0.45. That means 20,000. The demand will be 20,000. For 0.604, the random variable value which indicates the cumulative probability. What is the demand? 0.60. 0.60 is just above 0.45, is above 0.45 but below 0.76. This table represents the demand will be 40,000. Demand will be 40,000. In this way. What will be the demand for this random number? For this random 0.32, where it is just above 0.1 and below 0.5, that is 20,000. In this way, you can connect the demand which is at random with the help of this random number and relates to the cumulative demand in this way. Now, I have already mentioned, if you write anything to any cell, you will see the random number will be changed, and accordingly the demand figure will also be changed. Suppose I am writing 4 here. Automatically the random number has been changed because it is electronically connected, and the demand will also be changed. How? 0.45 is 0.4549 is above but below 75, that's why 40,000. In this way, 0.85 above 0.75, that's why it is 60,000. In this way, demand can be connected with the random number. What is our objective? We have to find out the best production units for which the profit will be maximum and the risk will be less. That I am going to discuss sequentially, slowly. Now, in this table, I will show how the profit will be computed. How the profit will be computed. The data in this problem is like this. Suppose the sale value per unit of the dairy is ₹25. Unit price means sale value. Unit price. Cost price of the dairy for production of 1 unit of dairy is ₹110. Unit scrap value. Scrap value means if your production units is more than demand, you can sell maximum the demand available in the market, and the excess production units will be sold in the market at the value of scrap, which is ₹20 per unit. If the unit produce less than the demand, then what will happen? If production is less, if production cannot meet the demand, then the customer may go to other organization for purchasing the dairy or product, and the goodwill of the company may lose, and in future that customer may not be returned to this organization. And for that, estimating from the past record, the goodwill cost is taken as 70 rupees. That means if demand is more, production is less, then for the gap of demand and production per unit, the goodwill loss is rupees 70. Now, how we will start? Suppose the production unit is 20,000. Just here I am going to show the process of calculation of profit. How we will calculate the profit first. Then we will simulate to calculate the profit over 500 units in this case, but you can do it for 5,000 or more than 5,000 also. That I will show how we do it. And the formula of random number is written here, random number, and this is the formula of VLOOKUP to get the demand for this random number. Just now I have already discussed the formula how you will get demand corresponding to this random number. In this case, the random number is 0.66. Lookup 1, that's why this range is related by lookup 1 name variable. Achha, the value is 0.669. Where it is 0.669 means more than 0.5 and less than 0.75. That's why the demand will be 40,000. The demand is 40,000. Production is 20,000 and demand is 40,000. And this demand comes from this random number. If you write anything to any cell, automatically this random number will change, and accordingly the demand will also be changed. The entire calculation will change, and we will take the help of that concept for different demand and production level, how you will compute the profit. In this case, only single data, taking single data, you calculate the profit. If this is the input, then revenue is, you have sold maximum 20,000 because though the demand is more, but you have produced only 20,000. That's your sell unit will be 20,000. Per unit sale price is 250. That's why this is the revenue amount. That is 50 lakhs of rupees. 50 lakhs. Only 50 lakhs. And what will be the cost? Cost will be, per unit cost is 110. 20,000 you have produced. That's 20,000 into 110. That is 22 lakhs. This is done through formula. You have written C4 into C1. Where is C4? C4 is this demand 40,000. Total cost is this 20,000 into C1 is at 20,000, C4 is the cost 110, 22 lakhs. And as the demand is more, production is less, that's why goodwill cost will have to bear by the company. How much? Per unit the cost is 70,000, 70 rupees, and the demand is excess 20,000, 40,000 minus 50,000, that's why 20,000 into 70, 14 lakhs. This is the loss for goodwill. Then what will be the profit? Profit will be 50 lakhs sale minus 22 lakhs cost, 22 lakhs cost, that means 28 lakhs, and minus 14 lakhs for goodwill, and this is the profit. And all these things are done through formula. You can check it. Total variable cost is, and goodwill, how will calculate the goodwill? If C1 greater than C2, money production greater than C2 demand, then it will be a case of excess production, and we will get per unit of excess production 20 rupees, and that revenue will be added to profit. But as this is not the case, C1 not greater than C3, therefore we will go for the option this. This is the formula from Excel I have taken. It is C3 minus C1. C3 is more, demand is more. It is C3 minus C1. This is the excess demand amount multiplied by minus 70, because it is to be reduced. And this is the goodwill loss, and this is the formula C8 minus C9. C8 is the revenue, C9 is the variable total cost, and plus C10, but the sign is negative, that's why it is subtracted. In this way you will get the profit. Now I have to show this is the profit for one iteration. One iteration means one production units and one demand. Demand comes through a random number. Now we have to calculate this profit amount for different options of production. Your maximum demand is 60,000. That's why we have taken the production units starting from 10,000, 10,000, 20,000, 30, 40, 50 and 60. And demand I have taken first by 10 observations, and later on it will be extended up to 500 observations, and for each observation we have to compute the profit amount with the formula mentioned at above. But it is a huge task, but I will show you the simple process is there. With the help of table you can do it in very easy way. Before calculation of profit, I am again going to show that the demand amount for different random numbers or probability, how it is computed. Just here in this place you write is equal to RND and copy it. Just drag it. I am not dragging it because if you again drag, the figure will again change it. And on the basis of that, the demand has been calculated, automatically computed with the help of the formula. That formula, VLOOP formula is written here. That again I am showing you 0.583. What will be the demand? 0.583 means above this, below this, 40,000. You see the demand is 40,000. Next, you check another 10,000. This one, the random number is 0.081. 0.081 means 0.08 means below this, above this, below this. That means 10,000. The demand is taken as 10,000. In this way, for 10 observations, I have shown how demand has been calculated and presented here. After this, what we have to do? For each level of production, for all this demand which is at random, what will be the profit? That we have to calculate by applying the formula, previous formula. And for all options of productions, 10,000, 20,000, 30,000, and for with the help of this demand, you can calculate the profit very easy way by applying the formula of table. That I am going to show you how. So one thing again I want to repeat, that if I write anything immediate in the cell, the formula automatically checks the different value, the value will change and the demand again will be changed. For that reason, for application of table, first you have to convert this demand which is calculated at random with the help of random number to values only. You remove the formula. You should not keep the formula. How we'll do it? That I am going to show here. You just select it and you copy and paste. Copy and paste to the same cell for value only. This is the value for value. Now you see that there is no formula, only the value. This value has been changed as I have put one strike here just to change it to value. That's why the value, but it is immaterial. You can delete it also, this number. It has no meaning. Now in front of us, this is the demand and this is the production units, and you have to calculate for all options the profit with the help of table. How you will calculate it? For that, what you will do first, you copy the formula. So where is the formula? C11. Just I have written here is equal to C11. There is this profit and this profit same. This formula I have written here. For application of table, what you have to do, you select the entire range for which you have to calculate the computation, and then from data table you go data and then see what if. This is what if, and then data table, and you have to put the formula first row. For row, what you will write? Row is production, that's why you production, and then for column means demand. Where is demand? Demand is written here, and you just put OK. Automatically you see all calculations has been completed. You can check any one, then you will see the computation is correct. So just for this figure I am going to show you 20,000 units is the production and 20,000 is the demand. What will be the profit? Profit is 28 lakhs. You see 20,000 is the production, another 20,000 is the demand, 28 lakhs is the profit. Again 28 lakhs is the profit. Wherever 20, now I am going to show the demand is 10,000 and 20,000 production, the profit will be 5 lakhs. The profit will be 5 lakhs. Demand 10,000, production 20,000. 20,000 production, 10,000. Forcefully I am writing 10,000. You will see the profit will be 5 lakhs only. Check, is a 5 lakhs. That means the calculation of profit for different production units and for different demand is correct. And now I am going to show you a separate table where after calculation we have taken the value of different production units and 500 observations of random number and demand. So we have taken the value only, as I have already discussed why we are taking value, because if you put the formula then that will reflect the anomalous figure, because after changing any value it will change automatically. That's why we have to do in that way. Now I am going to show what further calculation you have to do, and this is the table which we have done. Same method, after applying same method, the formula is, this is the profit formula. Here I have taken the data only. You have seen the formula for data only, just to analysis purpose, because we have removed the formula for avoid the complication problem. And this is the formula of demand. This figure has come after that process. You can do it in your laptop. I am just showing the process. And this is the production units, 10,000 to up to 60,000, and this is the demand up to 500 observations I have taken. And finally you can check it for any of this. Is say 40,000 demand and 10,000 production. You will set, you can check the profit will be 7 lakhs by the same method. If you put the formula, loss is there, I am going to show it previous sheet. I am going to show it again. The demand is 40,000 and production is 10,000. The loss will be 7 lakhs. I am going to previous sheet. So 10,000 is the production, 10,000, and 40,000 is the 40,000. See, the loss is 7 lakhs. This is calculated through formula. So in this way, that calculation is done and all values are taken. I am not going to show separately one by one, but this is done through the same process. Now, how we'll take decision? What will be the best option for production? That is our objective. Now, in this way, after calculation of 500 observations done here, and then what we have to do? Then average profit. This is the formula for average. This is the average profit if you produce 10,000 units. If you decided to produce 10,000 units, then your profit will be this. That means you will be in loss, because by considering 500 random demand, the calculation gives the result you will be in loss of 2,85,600. In this way, for 20,000 of production, 30,000 30, 40, 40,000 of production, all productions, the average profit has been calculated. The highest profit is showing 29,18,400 if you produce 40,000 units. This is the 10, 20, 30, 40,000 units. But if you produce 50,000 units, your profit will decrease to 26 lakhs something. If you produce more, then again your profit will decrease. If you produce less than 50,000, if you produce less than 40,000, then your profit will decrease. Then what is the maximum profit? Is this, for which option the production is 40,000 units, but only maximum production should not be the criteria. That's why the risks at the same time is also calculated here. Risks means standard deviation. For this case, the standard deviation is in this way. The standard deviation is calculated, and if we calculate the profit per unit risk, that means average profit divided by risks, then you will show this is the best result, because the per unit risks, 1.1 risks is this. This is the best result. In all angle, this is the best result. But sometimes we see few persons are risk averse. They don't like to take maximum risks. For that purpose, again, this calculation is being shown here. If instead of 40,000, if 30,000 units is produced, then how much profit will be decreased? The profit will be decreased. You can check. This is also done through formula. The profit will be decreased by, say, 25%. If you produce 40,000 units, whatever the profit, if you produce 30,000, then your profit will be decreased by 25%. But at the same time, the risk will be decreased by 52%. That means slightly your profit is being decreased, at the same time risk is also being decreased significantly. That means for risk averse person may select the production unit as not maximum profit option, that is for example instead of that 30,000 units. And for if you take the value of confidence level, then 29 lakhs 18,000, then for 95% confidence limit, that profit will vary in this figure. 95% confidence level, the lower value of the profit will be this and the highest value will be this. In this way, by applying Monte Carlo simulation, you can determine the appropriate production units by which you can get the maximum profit. Thank you. If you have any question, you may write to the comment box and definitely I will give the answer. And if you like this video, then please subscribe it and give like, so that in future we can give many important and good videos and which will motivate for the entire exercise. So again I am requesting, please give like option and also the subscribe for this channel. Thank you.